All right, guys. So today we are going to focus on configuring OSPF with a floating static route. Um, and this is really done just for redundancy. It's basically configuring a dynamic routing protocol on your routers. And if for any reason OSPF doesn't work properly, the static route will act as a redundant um, route to different networks, outside networks, etc. So let's go ahead and get started. We're just going to use the 2911 routers. We'll use, let's do four. So there we are. I zoomed in on this too to make it a little bit easier to see. All right, it doesn't have to be perfect, I guess, but all right, and it looks like we are going to need multiple networks here. So let's just make it easy. 192.168.1.0/24 for this. This one can be 10.10.10.0 slash 24 again. And this one can be 192.168.2.0/24. All right, so let's get started. We'll just have this automatically choose our connections, interface connections here. All right, and we can hover over 00, 10, 10. Okay, so this is going to be pretty easy. So what I'm going to do is the interface to the right will be .1, to the left, sorry. And the interface to the right will be .2. There we go. That should make things a little bit easier. Sorry, I know it's not the neatest. I'm going to put the .2 here, like so. All right, that's good enough. So let's get started. We'll configure from left to right. We're just going to do the interfaces first. We'll get them up with IP addresses set up. And then we'll move on to setting up OSPF. And then lastly, we'll set up the static routes. So let's go to command line interface. I'm going to say no every time this pops up. All right, enable conft interface G0/0. I'll say IP address 192.168.1.1 no shut. That's all we have to do for that interface for now. If you say do show IP interface brief, if I could spell, I guess, we can see that our interface, this is the 0/0 gigabyte Ethernet interface, is assigned the IP address that we gave it. It's up and down. This side is down because the connected interface is still in a down state. So once we bring that up, this will be in an up state, and they should be able to communicate afterwards. So, and we'll check it before we continue. All right, so for router, I guess we'll call it router 1. We'll say no, enable conft interface G0/0. We'll say IP address 192.168. Sorry, guys. .1.2.255.255.255.0. And then when I say no shut, you'll see that the green lights turn on and they will be able to communicate. But let's make sure. Do show IP interface. I was hoping tab would make that All right, so looks like 00 is in an up state. Can I ping router 0 from router 1? Let's find out. 192.168.1.1. There we go. The first ICMP message is lost due to ARP, or the router trying to figure out where this router is. But upon doing consecutive pings, you'll see that they always return as 100% packet transmission. So without further ado, let's do show write. Oh, well, wow. Oh, sorry, guys. Do write. Now, let's get interface, what was it, interface G0/1, I think. Yeah, 1, 0. Okay, so let's get 0/1 up. And we'll say interface G0/1. We're firstly gonna assign the IP address. So IP address 10.10.10.1 255.255.255.0. No shut. Awesome. Do show IP interface brief. I'm just going to double check my work, make sure I put the IP address in correctly the first time. So perfect. And again, this is down because this interface has to be brought back up. But we can see that 00 is up. So I'm going to say do show write. Oh, I'm sorry, guys. My brain is not braining today. Do show write. What the hell? All right, so we'll configure router 2 next. So we'll start with 00, make sure this can communicate with this, and then we'll continue down the line. All right, no enable conf t interface G00 IP address. I use tab to fast forward that or autofill it basically. This is 2. No shut. Do ping. And it should be 80%. Reaching to this one. Perfect. And we can see upon consecutive pings, all of them are 100 now. All right. And I'm going to configure the next interface before I say do show IP interface brief. So this one is 0/1. Interface G0/1. We're going to say IP address 192.168.2.1.255.255.255.0. No shot. Do write. Do show IP interface brief. And we can see the 10.10.10.2 network is up. The 192.168.2.1 is up-down, and that's due to this being not set up yet. You could also say do show run and hold down enter, and you can see the same information is here. So 0/2 isn't being used, so it's shut down by default. Same with VLAN 1 at the moment. Well, it's going to stay like that because we're not actually using any of those. All right, so that's set up. Let's go ahead and set up the last interface, and then we'll get started on OSPF. Okay, gig 00 is what I need to configure. No, enable conf t interface G0/0 IP address 192.168.2.2.255.255.255.0. No shut. Do ping just to make sure I have connectivity here. Should be 80%. And if it fails, then I know one of my configuration here is wrong. It's no big deal. 0%. So let's go see what I did wrong. Do show IP interface brief. And we can see I have this interface assigned .2.2. It looks good. Up. Let's just ping one more time just to make sure it wasn't something silly with packet tracer. Maybe I mistyped this subnet mask. So I use do show run. I can see the subnet mask. So 00 is .2.2. Subnet mask is good. Duplex is auto, which leads me to believe that this one is the misconfigured one. So let's just X out of here real quick. Double check. Okay. So let's see what we got on gig 0/1. And just to check the, I know I have it up already. Do show run 0/1, 2.1, 255.255.255.0. Oh, you know what? I pinged .1. Okay, I'm sorry, guys. This network is .2. Let me try that one more time. Yeah, of course it's not going to work. I'm trying to ping the network that's all the way down here. Sorry, guys. So this will work with 80% pass rate. Yep. And there we go. We are fine. All right. Sorry about that, everyone. But yeah, if you ever need to troubleshoot interfaces, do show run, do show IP interface brief are going to be your best friends. The last one being great to also check subnet mask, because if you mistype the subnet mask, it will fail. All right, so all these interfaces are connected and they are properly configured. Now, that being said, in order for me, I can talk directly from router 3, I can talk directly to router 2, but I wouldn't be able to reach these guys yet. And vice versa for router 2 for this one. And same thing for router 0 for this one and this one. So let's configure OSPF and get that fixed. We'll start from the left again and go to the right. So we'll make our router IDs is going to be all ones, all twos, all threes, and all fours. So let's go ahead and get started. Router 1 OSPF. Oh, I mistyped something. Router question mark OSPF question mark 1 question mark carriage return. All right, this is where I'm going to specify router ID first. We'll make it 1111. I'm also going to specify the connected networks. So in this case, it's going to be this. Wildcard of /24 is 000255. It's basically inverted. We'll make it area 0. All right. Okay, cool. This router is basically ready. Okay, next is this router. This one's going to be 2222. Exit router OSPF 1. Router ID 2222. Network is going to be, I'm going to include this one as well as this one, since they're both directly connected to the router that we are configuring, and I want these to be advertised via this router. So let's start off with, we'll start off with 10.10.10.10.0, because if I start off with this one, I'll get a syslog message and it will interrupt me. So let's go ahead and start with this one first. So 10.10.10.0. Wildcard of a /24 is going to be 000255, and we're going to make it all area zeros. All right, we're going to do the same thing, but with this network. 6, 8, 7. Do right. We'll get a syslog message in a minute saying these will become form neighbor adjacencies. There we go. That's the message we're looking for. Perfect. And I can say do show IP OSPF neighbor, and we can see this guy is our neighbor. I'm sorry, I should have configured. This naming scheme isn't great because this is 1111, this is 2222, and it's going to be and so on. So these have formed a full neighbor adjacency. Yeah, that's all we need to know for now. So we will go onward to this next router. So same thing, we're going to set up the routing protocol, which is OSPF. We will configure the router ID first, and then the network we want to broadcast to advertise. Sorry guys, I almost slipped up. So let's go ahead and start with this one first because of the syslog message we will get if we do this one first. So we'll say 192.168.2.0.000.255 area 0. Same thing, network 10, 10, 10, 0. Oh, 0.0.0.255 area 0. And I'll get. Oh man, I mistyped my subnet mask. Wildcard, I guess. There we go. Do right. Alright, cool. I might have to delete this. Let me just double check. I don't know. Because I got my syslog message here. Let's just make sure nothing crazy is happening. Do you show IP OSPF neighbor? So we have a full neighbor adjacency to this router. Perfect. That's what we want. At this moment, I should be able to ping this router here from this router. So let's just confirm that we can do that. Perfect, we can. Awesome. All right. I'm sorry, guys. I have just the biggest brain fart right now. I'm just going to do right. I feel like I forgot something. Nah, I'm sure it's fine. All right, and this is going to be our last one. This is going to be 4444. So I'll say exit router 1 OSPF router. Oh, OSPF 1. Sorry, guys. Router ID is going to be 4444, and we want to advertise the 192.168.2 with a wildcard subnet of that, and we'll get a syslog message saying, "Hey, we're neighbors now." Perfect. All right, so let's just make sure I can ping from to the very end. Awesome. Let me see what my routing table looks like. All right. So we can ignore the C and Ls because they're connected in local interfaces. Those are there by default once interfaces are brought up and are connected directly to the router. As far as OSPF, it's going to be these zeros here. And for router 3 in particular, how to read this is we're basically saying, good place to put this. Maybe here. Okay. All right. So we're basically saying for the first route of OSPF is using 10, 10, 10 to get to 10, 10, 10, 0, which is this network here. It's going to go through. Oh, sorry, I got lost. It's going to go through the 2.1 interface. So this interface here to get here. And for the second OSPF route, to get to the route all the way down here, the network all the way down here, sorry, we are going to basically move this around a little bit. Do the same thing. we're going to go to the next hop, which is this device, and it's going to carry us all the way to the network that we need to go to. So do right. Let's just check router zeros, IP route. Good, we have 2. Okay, that one should have 2 because we have 2 other networks we have to connect to. And the 2 in the middle should have 2 as well. No. This one should have. Do show IP routes. Yeah, here's our route to .2, which is all the way over here. The other ones don't need OSPF routes because they're directly connected to an interface on this router. So we have this connected to this interface, this connected to that interface, so it doesn't actually have to use OSPF. All right, now you see this number here? This is the administrative distance, or basically the route priority. And with routing protocols, so OSPF is 110. Anything higher than 110 and OSPF will be used first. Anything lower, so for example, if my administrative distance is 10 or 5, it will use the lower number first. So for administrative distance, just think the lower the number, the first number here on the left is, the more of a priority that it will have to be used. So we want OSPF to be the priority. However, we also want a backup method to route traffic over the internet if OSPF for some reason, or whatever protocol you're using, if it goes down for any reason, we need a backup. And that's why we're going to configure a static route. And I'll show you in a minute why it's called a floating static route. Let's go ahead and start. So for example, we will start with this router. I need to configure 2 floating static routes on this one. One to the 10.10.10.0 and one to the 192.168.2.0 networks. So let's get started. Exit, say IP route, and we will configure the one for this network first. 10.10.10.0 is a subnet mask of 255.255.255.0. I'm not using wildcard anymore because wildcard is used by OSPF. I'm just using a standard static route. And okay, so I got my destination in the subnet mask, but now I need to enter where my next hop is. And if I'm starting from this router, our next hop is this interface. So .2. 2.168.2. If I pushed enter right now, this route would take priority because by default, at least on Cisco Packet Tracer, the route will have an administrative distance of 1, and 1 is a lot smaller than 110. So in order for us to configure the floating stack route correctly so that OSPF will take priority while it's up and running, we will question mark, and we will configure distance metric this route. So this is basically asking for your administrative distance. And as you remember, OSPF is 110. So even if we made it 111, OSPF would have the priority. But let's just go ahead and say 150. Boom. And I will configure the route to 192.168.2.0, 255.255.255.0. And again, this one is going to have its next hop at .2. And we'll set it 150 as well. Do right. Now, when I say do show IP route, we should only see the O. Yep, because you're seeing what has priority. Later, I'm going to take off disable OSPF, and you'll see the static routes will be here, and you'll see 150 here as the administrative distance. But let me continue. I'm going to say do write, and I'm going to quickly go through the next ones. All right, so for router one, as far as the floating static route, I don't need one to this address. I don't need one to this address. I do need one to this address. So let's go ahead and configure that. IP route. Let me exit because I don't think I can do it from there. IP route 192.168.2.0. Subnet mask of 2/24. My next hop is going to be 10.10.10.2, 10.10.2, and administrative distance 150. Do right. That should be all I need to do for that router, because these two are directly connected. This one, same thing, but my route will have to be, I will have to make the IP route for this network here. So let's go ahead and do that real fast. All right. Exit IP route 192.168.1.0, 255.255.255.0. The next hop is going to be this interface here, and administrative distance will be 150. Do you right? Awesome. All right, the last one. This one is going to require two floating static routes. This one's directly connected, so we don't need one there, but we will need one to this network and one to this network as well. So let's go ahead and get started for those. Let's see. I can't see what my next hop's going to be. Okay, so it's going to be 1.2.1. Okay, so exit IP route 10.10.10.0, 255.255.255.0, and it's going to get there via 192.168.2.1. Oops, 150 is the administrative distance. Okay, I need another one to 192.168.1.0, 255.255.255.0. Next stop is going to be the same as previous. Say 2.1, administrative distance of 150. Do right. All right, and if we say do show IP route, we should still see OSPF O. Perfect. All right. So that is how you can configure the floating static route with OSPF. But to see if it works, I'll say no. Router OSPF1, and that should take off OSPF on this router. Do show IP route, and there we go. Our static routes have been set up. You can see the administrative distance. And like I said, I took off OSPF just for a minute just to see if my redundant links would pop back up. And as you can see, here they are, the static route going to the middle network, 10.10.10.10.0, and the far end network, 192.168.2.0, with the administrative distance of 150. Okay. And even if everyone else is still running OSPF, and I just have this one as the static route for the time being because that's a simulate OSPF not working for some reason, should still be able to route, and yep, we're good. Let me just